Liking this video will help this channel to grow. So please go ahead and give this video a like. Welcome to section 2, where we will be exploring solving equation with unknown on both sides of the equation. So far, I hope you have been finding this lesson helpful and have been engaging with the independent practice questions found in the description of the video. Now, let's start with the steps involved in solving equations with unknown on both sides. To solve linear equations with unknown on both sides, we follow the simple steps below. So, step 1, we expand brackets if there are any brackets involved at all. Sometimes there are no brackets, but if there are, we do expand the brackets first. Second is to simplify both sides of our equation. Then we need to move variables to one side and the constants to the other side, which is called collecting our like terms. And then we solve for the variable. Now, in part 1, we would have discussed how we go about doing the inverse of operations. Very important to follow the order of operations. So therefore, we are reversing our operations from the last thing that was done all the way to the first. We take care of all our constants first. A good practice here would have been to write the steps down so that when we're doing the question together, you can follow those steps. So we're just going to get straight into our example since we have already laid the foundation in part 1. So here we're given some linear equation. This time we've got two unknowns. You can see here that while in part 1 we only had like one variable, this time we have two variables, one on either side. Now guys, important to note as well, we do not only have to have x as our variables. Could be y, could be a, could be b, could be c, whatever letter we get, the same principle applies. So here we're asked to solve equations showing all working. First question is 4. This one has a bracket. 4x add 3 is equal to 2x add 6. So you know I love to rewrite my questions, so let's do that. So 4 bracket x add 3 is equal to 2x add 6. So the first thing we have to do here is to expand the bracket. So we have 4 times by x is 4x, and 4 times by 3 is equal to 12. Also, I just want to remind you, for those people who have not yet watched those videos on expanding brackets, you need to do that. Those are already uploaded. I've done expanding single bracket, expanding double bracket, and also expanding triple brackets as well. Very important for you to watch those videos to solidify your expansion skills. So we have completed here the expansion of bracket. So what we now need to focus on is to collect our like terms. Now remember, when we are doing our collection of like terms, once we're moving across the equal sign at all, we must do the inverse of the operation. So here we have 4x and we also have 2x. So it's a good practice to keep the larger coefficient where it is and move the other one to it, the smaller one. Now, especially for students who do not love to manipulate negative numbers, most of the time when you keep your larger coefficient where it is, it will result in a positive answer. Most of the time, not always, but most of the time. So here, I'm going to leave 4x where it is, and I'm going to put 2x on that side. Also, I'm going to put my positive 12 to the other side. Now, important to note here is that whenever we move sides, we also change the signs. So this 2x here is positive. Therefore, when I bring it to the other side, it will be the inverse. So it will be minus 2x. So 4x, this 2x coming over as a minus 2x. is equal to, I've got 6 left here, so I write my 6 that's left first of all. Now this positive 12 will now be minus 12 when I put it on the right hand side. Now my terms are together, so I've got my variables together and I've got my constants together. Now I just need to simplify both sides and then solve. So 4x take away 2x here is 2x. And 6 take away 12 is minus 6. Very important. I'm taking a large number from a small number. This is going to give me a negative answer. So if I look here, I've got 2x equal to minus 6. So I need to divide both sides by 2 in order to get x on its own. So x therefore is equal to minus 6 divided by 2 is minus 3, since a negative times a positive is equal to a negative. So minus 3 times minus 2 will give me minus 6. So that's how I know for sure my answer is correct. In the first section of this lesson, I've also shown you how to prove the answer. So you could go ahead and prove that if I substitute minus 3 in both sides, they will be equal. Now we go to part B, similar question where we've got 3x add 5 is equal to x add 11. Again, I'm going to collect my like terms since I've got 2 variables involved in this question. The largest coefficient is 3 for 3x, so therefore I'm going to take the single x to that side, and I've got 11 on this side. I now need to bring the 5 over to that side, so we're switching the sides here. So I've got 3x, this positive x will now be minus x equal to, I've got 11 left on the right hand side. I'm going to bring this positive 5 to the other side where we will now be minus 5. Beautiful. Now that I've got my like terms together, I'm just going to simplify and solve for x. So 3x take away x is 2x, and that's equal to 11 minus 5, which is 6. Now I've got 2x equals 6, so I now need to divide by 2 to find my answer for x. So x therefore is equal to 2x divided by 2 is just x, so 6 divided by 2 is 3. So my answer for x is equal to 3. Again, I can substitute them in both sides and see if they are the same. So we go to part C where we've got 4x plus 2 is equal to 2x add 10. What you could do at this point is to pause the video and try these two and then see would you have gotten the same answer that I would get. So 4x plus 2 is equal to 2x add 10. So again, moving 2x to this side and the 2 to the right hand side, collecting my like terms, I get 4x. This positive 2x will now be minus 2x. Remember, always the reverse of what I have in the question. So I've got plus 10 left, and I'm taking this plus 2 will now be a minus 2, the inverse of plus 2. So 4x take away 2x is 2x, and that's equal to 10 minus 2, which is 8. Now I need to do the opposite of multiplying by 2 on both sides. So dividing by 2, 2x divided by 2 is just x, and 8 divided by 2 is 4. So x is equal to 4. Brilliant. I hope that you got that on your own if you pause and try. So next one, I've got 4x minus 3 equal to 2x add 5. Again, moving 2x to the other side and minus 3 to the other side where numbers will be together, variables together. So 4x, positive 2x will now be minus 2x. I've got 5 left on that side. Notice I always put what I have left first, and then I'm bringing minus 3 to the other side. The opposite of that is plus 3. So 4x take away 2x is 2x, and that's equal to 5 add 3, which is 8. Now I need to divide by 2 on both sides. So x therefore is equal to 8 divided by 2, which is 4. And just like that, we have simplified that answer. So guys, I hope that you're enjoying this exercise so far. And if you haven't yet liked the video, go ahead and give it a like. So let's get on to our next question. So here we are asked to solve 4p minus 3 equal 5p minus 5. So again, I'm just going to rewrite this. So 4p minus 3 equal to 5p minus 5. So we know first of all we need to collect our like term. So this time you can see the larger coefficient here is 5 for p. So I'm going to put 4p on this side and I'm going to put minus 5 on the left hand side this time around. Now it's not bad if you put the 4p, keep it where it is, and put the 5p there. It will result in a negative, but you will still get the correct answer after you have completed the question. But just to spare yourself the trouble, if you know you're not good with negative numbers, then keep the larger coefficient where it is. So that's what I'm going to do. So here I have minus 3 left. If I put 4p on this side, I'm now going to take the minus 5 to the other side as a plus 5, inverse of the operation. This side I've got 5p. Therefore, I'm going to put 4p on the other side. Now, a positive 4p, the opposite of that is minus 4p. This one will get us straight to our answer, you'll see. So here, minus 3 add 5 is the same as 5 take away 3, which is 2. And then 5p take away 4p is just 1p, which we write as p. Therefore, p is equal to 2. Now, I think it's important to show you that if you had done it the other way around and how to navigate this. So I'm just going to do it for just this one question. So 4p minus 3 is equal to 5p minus 5. Now, if I put 5p on the left-hand side and minus 3 on the other side, I would have 4p minus 5p equal to minus 5, and my minus 3 will now be positive 3. If you look here, 4p take away 5p is negative p. And that's equal to minus 5 add 3 is minus 2. But I cannot have a negative variable. So what we would need to do is to multiply each side by negative 1. So it could either be multiplication or division by minus 1. So negative p times positive 1 will now get me my positive p. And negative 2 times negative 1 is equal to 2. Now we've got the same answer. So if you chose that route, you would now have to either multiply or divide by minus 1 to get your subject, which is p positive. So either way is okay. You've got to know what works for you. So we go to part B here, which asks us to solve 3t minus 8 is equal to 6 minus 4t. So again, positive, I've got a positive 3t, which is greater than minus 4t. So I'm going to put the minus 4t to the left-hand side and put my minus 8. Remember, we change sides, we change signs as well. So 3t, I'm going to put a minus, the reverse of minus 4t is positive 4t, and that's equal to, I've got 6 left on the right hand side, minus 8 will now be positive 8, that's the inverse. So 3t plus 4t is 7t, and 6 add 8 is 14. Now we need to divide by the coefficient 7 on both sides. So 7t divided by 7 is t, and 14 divided by 7 is 2. And again, I've shown you how to prove your answer. So go ahead, prove your answer by substituting 2 for t on both sides, and you should get the same numerical value for the answer. Beautiful. So next questions involving some brackets now. So remember we spoke about the fact that we've got to expand all brackets first and then apply the principles of collecting like terms and doing the inverse of our operations. So again, we're solving the equations here. We've got 4 bracket 2x add 1 plus 5 bracket 3x add 2, and all of that is now equal to 83. So 2 sets of bracket to expand. So 4 times 2x is 8x, and 4 times 1 is 4. Now, a common mistake to make in questions like these is to forget that you must multiply all of the terms in the bracket by the term outside. You cannot forget that, else you will be wrong completely. So we need to do positive 5 times by 3x, which is 15x, and also positive 5 times by 2, which is 10. And that's equal to 83. Now we need to collect our like terms. So I've got like terms 8x and 15x added together. 8 add 15 is 23. So 23x, and 4 plus 10 is 14. And that's all now equal to 83. Now the next step is to subtract 14 from both sides. So minus 14 minus 14. So here 14 and minus 14 is 0. So we've got 23x left on that side. Now 84, so I just do that quickly on my calculator. What is 84 take away 83 take away 14? So 83 take away 14 is equal to 69. I could use my column method as well. Last step is to divide by 23 on both sides. So dividing by 23, I get x equal to 69 divided by 23 is 3. So x is equal to 3. You can see here more things to do, but we are prepared for each part. We've learned how to expand our brackets. We learn how to collect our like terms. We learn how to rearrange a formula to make a particular variable the subject. So let's do another example, this time involving a negative. So I've got 5 bracket 2x add 3 minus 2, 3x add 1 equal 29. Now this is very, very important here. Lots of people make mistakes here, not paying attention to the fact that the 2 here, this is not just a 2 on the outside of the second bracket, but it's a minus 2. So when we are multiplying, we must say minus 2 multiplied by all the terms in the bracket. So let's go. 5 times by 2x is 10x, and 5 times by 3 is 15. Now minus 2 times by 3x is minus 6x, and minus 2 times 1 is minus 2. So now we've got some negatives here. Collecting like terms, important to see. We've got 10x, but this one is a minus 6x. 10 minus 6 is 4x. We also have positive 15 minus 2, which is positive 13. And that's equal to 29. So again, we need to solve the equation now that we've simplified it. So we need to subtract 13 from both sides. So 4x is equal to 9 take away 3 is equal to 6, and 2 take away 1 is 1. So 4x is equal to 16. Last step is to divide by 4 on both sides. So 4x divided by 4 is x, and 16 divided by 4 is 4. So x then is equal to 4. Absolutely fantastic. Now guys, we've got 2 questions to go, and then we are going to summarize. So the sides of a rectangle are shown below. So we did something similar into part 1 of this lesson. However, this one relies on our on our ability to remember the properties of our rectangle. So the sides of a rectangle are shown below. We're asked to find x and hence find the perimeter of the rectangle. Now the word hence here in any question means that having done this in part 1, use that answer to find the answer to this question in part B. So it is a linking question. So we're told to find the value of x and then as a result of finding that, find the perimeter. Now for this question, our breaking point here is to remember that the opposite sides of a rectangle are parallel and also equal. This is how we're going to now form the equation with terms on both sides. So I know that 3x minus 1 has to be equal to 5 minus 9x since they are parallel, hence equal for the rectangle. So we go ahead and form the equation. 3x minus 1 is equal to 5 minus 9x. What we now need to do is to collect our like terms and solve the equation for x. When we've done that, we would now have enough information to substitute into the question and solve for the perimeter. So let's collect our like terms. So I've got 3x here. I'm going to now put minus 9x to the left and minus 1 to the right to bring my constants and my variables together. So 3x, my minus 9x is now positive, the inverse of that operation. And I've got 5 left on the right hand side. My minus 1, the inverse of that is a plus 1. Beautiful. So now I'm doing 3x plus 9x, which is 12x. And that's equal to 5 plus 1, which is equal to 6. Now to solve for x, I need to do division by 12. So dividing both sides by 12, guys, here is where lots of people make mistakes. Remember, I'm doing 6 divided by 12 and not 12 divided by 6. So my answer is not 2, but my answer is a half, which I'm just going to write as 0.5. So the value of x is a half or 0.5. Now I'm going to go ahead to find the perimeter. So what I've got to do here is to substitute the value of x into any side of the rectangle that I do not yet know the numerical value. So I'm going to substitute it in 3x minus 1 to find this length of the rectangle here. So remember, number and letter beside each other indicates a multiplication. Hence, I'm doing 3 multiplied by a half. So 3 times 0.5, take away 1. Now, if I get that answer, I don't have to do 5 minus 9x because both sides are equal. So if I get the answer for this bit, I also know the answer for the parallel sides. So let's go. So 3 times by 0.5 take away 1 is equal to, let me just put that here so I don't make a mistake. So that's equal to 0.5. So therefore, I know that this side of my rectangle is 0.5 and the other side is also 0.5. Equally, this side of the rectangle is 4, the other matching side, opposite and parallel, is also 4. Now I've got all the information I need, I can now find the perimeter. So let's go. The perimeter therefore is going to be equal to 0.5 plus 0.5 plus 4 for this side plus 4 for the other side. So 4 plus 4 is 8. 0.5 plus 0.5 is 1. So we're essentially doing 8 plus 1, which is 9. And the unit given is centimeters. So the perimeter, therefore, is 9 centimeters all around. I want you to see the application to different topics across the curriculum. Very important to be able to apply. This is where we pick up our 3 and 4 markers, that ability to make connections with all the topics in our curriculum. And guys, we're now going to do the final question. Again, this question speaks about the isosceles triangle, so we're integrating the properties of triangles here. So if you're given this question and you did not know what the word isosceles mean, you would not have broken through successfully to finishing off this question and scoring all possible marks. So in this isosceles triangle, keyword here, underline, the sides are described as shown. We're asked to find x and again, hence calculate the perimeter of the isosceles triangle. Important to note here the symbols given on the diagram. Now, the question did not have to tell you it's isosceles. We would have just shown the two lines inscribed on the shape. Those two lines here indicates equality of sides, hence indicating an isosceles triangle. Now we know that an isosceles triangle has two sides equal and also two angles. It reasons then 2x plus 1 has to be equal to 4x minus 7. So again, with that knowledge, I now form an equation in x. So 2x add 1 is therefore equal to 4x minus 7. Again, I collect my like terms and solve the equation, giving myself the numerical value for the two equal sides of the isosceles triangle. So coefficient 4 is greater than coefficient 2 for x, so I'm going to put 2x on this side and minus 7 to the other side. So therefore, 1 minus 7 is now plus 7 for the inverse. And I've got 4x, my positive 2 is now minus 2x. So 1 plus 7 gives me 8, and 4x take away 2x is 2x. Now I need to divide by the coefficient of x, which is 2, on both sides. So 8 divided by 2 is 4, and 2x divided by 2 is just x. Therefore, we can conclude x is equal to 4. Now I've got the value of x. I now need to substitute that in either side of the isosceles triangle that's equal to get a numerical value. So let's do it in 2x add 1, 2x plus 1. Now x is equal to 4, so 2 times by 4 plus 1. 2 times 4 is 8. 8 add 1 is 9. Therefore, each side of the isosceles triangle is 9 centimeters. Now we finish off by adding all three sides. So the perimeter is equal to 9 centimeters plus 9 centimeters plus 3 centimeters. 9 plus 9 gives us 18. 18 plus 3 gives us 21. So the perimeter of the rectangle is 21 centimeters. There we go. So the difference between ordinary and extraordinary as it relates to result is that little bit of extra, that ability to take opportunities and apply concepts from one topic into another topic across the curriculum. Now guys, thank you for staying with me, and it's now time for our key takeaways. So we spoke about solving equations where we've got unknown on both sides. Talk about step 1. If we've got brackets involved at all, we need to expand those brackets first. Step 2, we simplify both sides as you would have experienced as well. Then we collect like terms, which involve moving terms to one side, variables to one side, constant to one side. And then after that, apply the inverse method of operation to solve the equation for the variable that we are given. And once we've done that, we should be able to apply to any concept at all across the curriculum. Beautiful. Now guys, I cannot stress enough how important it is to stay connected by getting that notification bell on so you can see when the other sections are uploaded as well. And please take advantage of those questions that you're given for your independent practice that you can find in the description of this video. Share, like, subscribe if you haven't yet, and remember guys, we are also on TikTok where you can do additional practice questions. Until the next upload, thank you so much for watching.